Okay, this video is like the marking schemes, a marking schedule, tick list that we will use when we mark. So the actual assessment, this is not exactly going to be the same because the assessment's not going to be the same, but the one that we're actually practicing on, this is what we're looking at. So what we need to look at first is the achieve criteria. So you've got to do, I'm going to tick it off, and I want you to tick it off as you go. Have you said what tool you're using to generate random numbers? So that's where you say it's my calculator and I go
10 random hash plus.
yeah, but it won't necessarily be 10. It's only 10 in this one.
So random hash plus.
Yeah, but the number in the front you need to intellectually calculate. Okay, so then the T for table, the next achieve thing, you've got to have your table of random numbers and what outcome that means. So in the fruity freezers, number 1, some of you decided it was strawberry. Other people might decide it's apple. Everyone's might be slightly different. But the thing is that the probability should be the same. So if you've got 10 numbers and 2, for example, are bananas, it doesn't matter which 2, as long as 2 out of the 10 are for bananas. Make sense? So that has to be mathematically correct to pass. And you have to sometimes calculate that. You've got to define what a trial is. What does it represent? So in the fruity freezers, what does a trial represent?
Like one time that she's buying fruit.
Yeah, so one time where she has her 10 ice blocks, is it?
Yeah,
Yeah.
10 days of buying one ice block.
Yeah, so one trial is 10 days. When would it end, that trial?
After 10 days.
Yeah, now what's interesting about that particular assessment is that you're then asked the average number of days it takes to win an ice block, and then you actually have to go past 10, because if you've got to 10 days and you don't have your 4, to win your movie ticket, you don't have your 4 fruits, you have to keep going until you do have your 4 fruits. Does that make sense?
Yeah.
And then that might take 14 days or 15 days. And then you've got to go back through the ones that have done 10 days and you've got, yes, you've won the movie ticket. How many days did it take before you won the movie ticket? So then you add up all those numbers, and what would you divide by? The number of trials. Fantastic. That's your merit level. To pass, the chance of winning the movie tickets is all you need. Have you recorded the results? Okay, so that you've got a table for that. You've got to do at least, in this circumstance, 15 trials. But remember, so in this particular one, you had to have at least 15 trials because each trial had at least 10 numbers. So that would be like 150 random numbers that you'd be generating. With the canoe one, you wouldn't have been able to do 15 trials because one trial was so much more complicated. So you only did maybe a couple of huge trials. You must calculate. So you can calculate the number of successful trials divided by the total number of trials would give you the number of successful trials divided by the total number of trials would give you the
total
the number of successful trials divided by the total number of trials would give you so it actually gives you the probability of success. Okay? So this is a huge concept. If you're missing, you've got to actually do some work here. The other thing how to calculate the average, you need to get, like I was saying before, all the different lengths of days that it took to win the movie ticket, add them all up, divide by the number of trials. So for merit, you need to get both, but for achieved, it's just one or the other. So the easier one is actually the probability. So it's the number of successful trials divided by the total number of trials. It's the likelihood of winning. Does that make sense? Mm-hmm. Yes, good. Okay, Then you've got to write a estimate. I estimate that the likelihood of her winning the ice block sticks is this. Okay? When you're wanting merit, you have to go into assumptions. You have to estimate for both the average and the probability. Okay? Now, also for merit, you need to talk about variability. So basically the idea is you're all doing the same simulation. You're not all going to get the same answers. So what you're doing is an educated guess. That's why we call it an estimate. It's not the actual, but it's a good guess. It's an estimate. So you've got to talk about that variability, that although my simulation got this, my friends may have got something slightly different. So it's only a guess. And the other thing is sensible rounding. Okay, so you don't want to have like 1 million decimal places, but you don't want to round it to a whole number either. Okay, so it's just got to be in context sensible. Now for excellence, you can see you just had to do make sure you do a few more trials. That was the same as merit, that's the same as merit, that's the same as merit. All of those are the same as achieved, the way I've got this. So for excellence, you need to have the potential effect on the simulation, another assumption and its potential effect on the simulation, and a reflection on the process, and identify potential issues of accuracy. So I can go through that with the people who are actually at that level. Okay? Any questions?
What's the assumption? Is that like saying that it'll take her?
For example, it's like you're assuming with the ice block sticks that the probability stays constant, but what happens if one particular shop ended up with all of the ice block sticks that had pineapple on them? You know, it depends how. It's a little bit like when you get a lucky dip thingy for lotto or something like, is it lotto? No, instant kiwi. Does your probability decline over time? Because I mean, someone might have already won that particular series, if you like, when you're actually buying the ticket. So over time, you've got maybe less and less chance. So those kinds of things, like were they evenly distributed?
Yeah.
Is it, is the probability really constant? That kind of thing.